Okay, we're going to take a look at one of the main concepts of coordinate geometry, and that is the median of a triangle. And medians are quite simply just lines that come from a vertex of the triangle, and they hit the line opposite at the midpoint. That's it. It just cuts the line in half, and it hits from the vertex to the midpoint of the opposite line. That's the midpoint. The interesting thing about it is if you draw all three of these medians into a triangle, they intersect or come together at a single point. And that point is called the centroid. The centroid is basically if you took a cardboard triangle and you tried to balance it on the edge of the tip of a pencil or pen or something, the point where it would actually balance on that tip is basically that centroid. That's the center of balance of that triangle. And that's where those three medians come together at a single point. It's called the centroid. Now let's say we wanted to prove that the medians of a triangle are concurrent, that they all intersect at a common point. So let's take a look at what that might look like. So if we constructed a triangle, let's just construct a triangle, any old triangle. Okay. Now let's say we wanted to draw a median for this triangle. We'd have to identify the midpoints of each of those lines. So let's just say I label this. I think I can label it. Can I? Yeah. I can label it A, B, C. Okay, so the midpoint of AB is this point here. I'll call that D. And the midpoint of BC is E, and the midpoint of AC is F. So the nice thing about Desmos is it does that for us, but you're going to have to do that. You're going to have to find those midpoints using the midpoint formula and so on, but we found them. Now all we have to do is draw a line from the vertex to the midpoint, and we've created a median. Okay, so that's our first median, and we can do that again. You can just go to from the vertex of B and go to F, and we've created our second median, and we can do that again. We can go from C, the vertex, to D, and we've created another median. And you can see that all three of those medians that we have created intersect at a common point. And we can call that whatever you like. You can label that G. Now, how would we prove that if we didn't have Desmos drawing that, right? So this is the beginnings of things. So if we go down here, and we have a triangle drawn, and we have coordinates A, B, C. Now, what we're going to need to do in order to prove the medians of a triangle are concurrent, meaning that they all come together at a single point, they intersect at a common point, is first of all, we're going to have to find and calculate the midpoints of AC and AB and BC. We're going to have to calculate those, and then draw our median lines in from the vertex to the midpoint, from C to the midpoint, from A to the midpoint. So we're going to draw the lines in, and then we're going to have to find the equation of all three medians. So we've got to find the midpoint, then we've got to find the equation of all three medians, and then either through simultaneous equations, or your calculator can also do this, we have to find the point of intersection between all three medians to prove that they are concurrent, to see if they do in fact go through a common point. So that would be your job next, is to do that exact activity.